All right, so I'm going to go over natural gas and fracking. Okay, so natural gas is something you're probably familiar with. Most likely you're familiar with, a natural gas stove or possibly a natural gas uh, heating equipment, so a furnace. Um, the question is, what is natural gas? I mean, you probably know that it's something that burns and you can generate heat with it. But natural gas, as it turns out, is mostly made of methane. Okay, so methane, the chemical chemical name is CH4, so this is something you should be familiar with, CH4, and that is carbon and 4 hydrogens. So the molecule is carbon and 4 hydrogens, excuse me, and that is methane. So natural gas is mostly made of methane. The stuff that you see burning here, the energy that is in natural gas is the methane, okay? So pure natural gas would be pure methane. Now there's always going to be some kind of um, impurities in there, but methane is really what natural gas is, okay? So as we've gone over in a previous class, it's formed from ancient organic material, primarily things like diatoms that were, over an ancient ocean and they sank to the bottom, got buried by sediment and so forth. So when all that happens, so that's why it's buried, right? So you have all this ancient, excuse me, dead organisms that over hundreds of millions of years basically got metamorphosed into natural gas, and then they seep into pores of rock. So this gives you a pretty good schematic of how natural gas is, excuse me, usually extracted. So the conventional way is these sort of, the regular old oil wells or natural gas wells. You bore straight down. If you use seismography, so you use, basically radar equipment, and then you find where the natural gas formations are. So, they know the geology well enough that they can sort of have a really good educated guess where the pockets of gas are going to be. So you find a spot, you drill down, and then with the traditional drilling or conventional drilling, you just drill straight down and you find this pocket of natural gas, and then you can extract it. Now, the newer ways that we'll talk about in a minute, something called directional drilling, is where you can actually drill down and then you can actually turn your drill bit to drill in really any direction. So they could actually go down here, they could kind of follow this path, okay? So this is called directional drilling. This is how, the basis of hydraulic fracturing or fracking. And again, you can see why, this is beneficial. If you would drill a well straight down and you would just pass right through this layer and you only hit this little area. Okay, so if you can change the direction of your well, you can actually follow this. I mean, these wells can go for miles in a horizontal direction. So that's been the really big innovation recently. And they're also, like I said in a previous lecture, the natural gas and oil are often found in the same areas. They're actually coal and methane are often associated. So you'll often find natural gas along with coal, which is one reason why coal mining can be dangerous, is if there's natural gas pockets in there, very flammable, and so you have to be careful with that. Um, one I think interesting aspect of natural gas, you're probably familiar with that sort of, it's a very distinct smell that natural gas has. As it turns out, the smell that you smell is not the natural gas. Okay, so natural gas itself is actually colorless, odorless, tasteless. You have no idea it's there. Um, so when they process natural gas, so after they pull it out of the ground and they process it, um, they add this a chemical called mercaptan, and that actually gives it the smell. So they do that for safety reasons, to make sure you can sense natural gas, at least because it's so dangerous, because of the flammability. So if you look at the overall natural gas use, this is the most recent data. This is from a 2015 document. This was from your reading. So if you look at the natural gas use, you can see, the breakdown here. Even though residential, would be, in houses, that's probably the thing you think about first when you think about natural gas. It's really only a small percentage, about 90%. It's about a fifth of all natural gas use. So most of it's used for electric power and industrial processes. And there's some commercial, that's just commercial buildings like schools and, stores and hospitals and that sort of thing. So that gives you an idea of how we're using natural gas in the United States. And now in terms of the residential sector, about half the homes in the US use natural gas for heat. Of all the energy that's used in the United States, so all the energy, we looked at energy mix in a previous lesson, all the energy in the US, about 28%. So we're looking at 25 to 30% on average of all of the energy use. That includes all the oil, coal, all that stuff. That natural gas is about 28%. Some important environmental considerations. This is all from your reading, so this is a rehash. One of the biggest benefits that people point to for natural gas is that if you take an equivalent amount of natural gas and you take the same amount in terms of its BTU content, so the energy content, and you take a pile of coal, so you say hypothetically I have 100 ccfs of natural gas, a certain amount of natural gas, and then the amount of energy that's in that natural gas, if you take an equivalent amount of energy that's coal, and if you burn both of them entirely, natural gas emits about 50% of the emissions, okay? So if you burn it, it's a lot cleaner than coal. Again, so methane is the reason why it burns cleaner, it just burns cleaner than coal. However, this is very important. It's made almost entirely of methane. The problem with methane is that if you do not burn it, okay, so if it leaks out, methane is about 30 times worse than carbon dioxide in terms of greenhouse gas. And we'll get into greenhouse gas and climate change and all that in a future lesson. But these are two really, really important things to remember. If you burn natural gas, it emits about 50% of the carbon dioxide. If it leaks out, it's about 30 times worse than carbon dioxide. So this is kind of this, it's an important consideration that if we're going to use natural gas, it better be burned, otherwise it's worse. And then so methane leaks are a big problem in the U.S. These are estimates, about 2% of U.S. greenhouse gas emissions are from methane. And generally speaking, natural gas is lower on other emissions, nitrogen oxides, sulfur dioxides, like particulate matter, things that cause asthma, that sort of thing. So natural gas is overall a much cleaner energy source than coal. However, it becomes a problem if it leaks out. Now, the process of drilling it's not clean. I mean, it's loud. It's there's pretty strong odors. There's some issues with drilling. And also pipelines can be a little bit of a problem. I mean, you don't really want a pipeline in your backyard or near your backyard. They're not the worst thing in the world, but they are kind of intrusive. Okay, so there's some general considerations about natural gas. So let's look at the natural gas supplies through time. So I want you to press pause and take a look at this chart and take a look. So here's our date on the x-axis, and then this is the trillion cubic feet. So this is the amount of natural gas. Okay, so amount of natural gas and the year. So we go from 1949 to 2014. Okay, and so the blue line is our consumption in the United States. The orange line is our production in the United States, and the green line is our imports. So I want you to sort of press pause and think about some trends that you see in this line, in these, the consumption, production, and imports. And then press play and kind of take a look. So if you notice, from the early days of natural gas all the way through, it looks like about 1985, okay, production and consumption were basically equal. Okay, so there were little discrepancies here and there, but overall, for the most part, we were producing what we used. That's what that means. Now we started to add a few imports early on when our consumption was a little higher. You can see consumption is a little higher than production here. So we had to import some natural gas. But by and large, until about 1985, 1986, we were good. Then about that time, we started using more, so more consumption than production. So what should happen in imports during that time? It's not coincidental that the imports go up at the same time. So if we're using more than we consume, we have to add imports in order to supply what we need. Okay. Another thing you probably notice, or trend that you notice, is right around this time, right around 2005, sharp increase in production, sharp increase in consumption. If you notice about that time, imports went down. Why is that? Because if you notice, these lines are starting to get closer together as you move forward to 2014. So by 2014, we're producing almost as much as we make, or so we're producing almost as much as we use. So we didn't have to import that much. And so this point right here is a really critical time. And as it turned out, what happened there, this is where fracking really came into the fore. So I want to show you another chart here. This is natural gas, what's called proved reserves. So proved reserves, and this is from your reading. Proved reserves shows, again, this is from 1983 to 2013. So this shows through time. You can sort of focus on the blue line. This is the U.S. total proved reserves. So proved reserves, estimated quantities that analyses of geological and engineering data have demonstrated to be economically recoverable from known reserves in the future. Kind of a big word salad. What that really means is that this is scientists' best guess of how much more we can economically get out of the ground. This is really important. This is very scientific. I mean, they use as much, information as they can. We can't see under the ground, or we can't see everywhere under the ground, so we don't really know how much is there. But we, based on geology and what we know about natural gas deposits, we have a pretty good idea, probably, of how much natural gas is under the ground. So we take that into consideration, but a really, really, really important part of this definition is this economically recoverable part, because what this line is telling you through time, not only how much gas is there, but based on the current technology, the price of natural gas, and all that, they take all that in consideration, and they say, all right, well, based on how much, we know how much is there, we know where it is, we know how expensive it would be to get out, and this is how much it would cost, and how much we can make from it. So they take all that in consideration. And this is really a chart that tells you not how much gas is there, but how much gas is down there that we can sort of extract and still make money by extracting. Okay, so I think a really interesting question, and I want you to press pause and think about this, is how can you think about this, we keep consuming gas. In recent years, we've been consuming more and more and more. So if we keep using all this natural gas, and yet somehow during that period of time, our supply of natural gas, so the amount of natural gas available to us, continues to increase. So think about that. It's kind of a weird disconnect between consumption. You would think, okay, we have this big pool of natural gas under the ground. If we use more of it, that number should go down. We should have less and less over time because we keep using more. But if you look at our proved reserves chart, it actually goes up over time. And so the question is, how did that happen? And one thing you might notice is right around this time, right around 2000, 2001, we were pretty flat with proved reserves, and then all of a sudden we have this huge increase in proved reserves. So I want you to think about what might have caused that. So what happened really was this fracking boom. So hydraulic fracturing became widespread. The technology advanced significantly to the point that the technology got so good that we could economically recover more natural gas. So before fracking was a big thing and the technology was so advanced, we had an idea that the natural gas was under the ground, but we really had no way to get to it. So once we developed the technology, it started to become economical to get more natural gas out of the ground, and so that's why we had more proved reserves. So there's not more natural gas in the ground, it just means we can get it economically. So we can make money from it because of the improvements in technology. So fracking or hydraulic fracturing. So I suggest you open this PowerPoint that's posted and watch this video. And he does a pretty good job of explaining what fracking is. So one or two things I want to point out. So as I said, directional drilling is a process whereby you can actually move the drill bit and force the well to go sideways. Okay, so that was the big advance, the one that made all this happen. Hopefully you watched the video. You'll note that fracking is, we knew about fracking in the 40s, 1940s. But the big advance was this directional drilling process. Okay, so we knew that we could get more oil and natural gas out of the ground by using this hydraulic fracturing process. But once we got developed the technology to move the direction of our wells underground, that's where we really, because going back to this original illustration here, so if we don't have directional drilling and we just drill straight down, we're only going to hit this little part of so we could frack this little part, but once we got directional drilling, we can force the well bore to go that way, and then we can frack all along this layer, okay? So we have access to more, it's easier to access more gas, okay? So that was the major technological advance that allowed for the proved reserves to increase over time. And so I think an interesting thing to reiterate is that this fracture, so this is your shale layer. So the thing that actually fractures the shale is water. So you just pump water at extremely high pressures. So you basically have this perforated tube that you force the water into, and then you pump it at such a high pressure that it actually cracks the rock underneath the ground. So the water cracks the rock. It's not like they're exploding, these big charges that blow the rocks apart. The fracture happens from water, which is why it's called hydraulic, right? Water, hydraulic fracturing. Okay, that's what fracking is. Okay, so this uses an awful lot of water, thousands of gallons per well. So some of the issues that can pop up, it can leak and destroy water supplies. So there is evidence, verified evidence of fracked wells leaking and destroying, other people's drinking water wells. Now, one of the problems is when they pump this water down, as they mentioned in the video, the water doesn't stay down there. Most of it actually comes back. So they actually pump the water down, frack the rock, pull the water back out, and then they pull the gas out after that. So the problem is you have all this extra what they call flow back. Okay, now the problem is there's two sort of problems with. One, they add all these chemicals, as they mentioned in the video. They add chemicals to this water before they frack it. And the problem is when you put water underground, it actually picks up on little chemicals that are in the ground, and it'll pull things like radium, radioactive material, and other little impurities that they suck back out, and then they have all this water has all these toxins in it, and sometimes it's mildly radioactive. And so they have to do something with that. So that's a big problem. Okay. They used to just put in our wastewater treatment plants, and they realized that they can't do that anymore because they don't have the capacity. So a lot of times what they're doing is they'll take this flow back, the wastewater, and they'll find other places, and what they'll do is they'll actually inject it underground to put it back in the ground. All well and good, except one big problem with with injection wells is that they can cause small earthquakes. So this is verified by the U.S. Geological Survey that the fracking itself, this is important, fracking itself does not cause earthquakes, but there are cases where the injection wells getting rid of the wastewater does cause earthquakes. And you could Google fracking and earthquakes, and a bunch of things will pop up. They are sometimes some pretty big earthquakes. Leaking methane is a problem, so it's notoriously leaky, and the wells can be leaky, and then sort of the pipelines can be leaked, as we mentioned. As I mentioned earlier, methane is very potent greenhouse gas, so you really don't want that leaking out. So if you look at the fracking, the areas of fracking in the U.S., they're what these shale plays. So you may have heard, if you live in Pennsylvania, maybe you've heard fracking is really big in this. This is primarily called the Marcellus Shale, but there are some other shale deposits. So this area, if you think of it as underground shale layers that are deep underground, sometimes miles into the ground. Big fracking area here. Texas is a huge fracking area. North Dakota is a big fracking area. They're having some issues with fracking in the west. You notice this is in western Colorado. One of the problems with this, think about it, you're using thousands and thousands of gallons of water in an area that's already water stressed, so that can be a big problem. So we're only scratching the surface. There are so many issues, both good and bad, with fracking that we're really just scratching the surface. But just know that water is one of the major issues. But also, I mean, the land use and having these big machines and everything in people's yards is a big problem. This is a picture of one fracking operation. I mean, I don't know that they all look like this. We see there's a lot of really big trucks, huge equipment. So if you know anything about this area of Pennsylvania, in particular, it's very rural, very small towns, a lot of farms, just a lot of forest. So one of the big problems with fracking, and the complaint that a lot of people have, is that you have these tiny little rural areas with these small roads, and they have these semi trucks just 24/7 going in and out with water and wastewater. So, and other, equipment. There's loud, there's noises, there's drilling, there's all kinds of stuff. So it's a very loud process, very industrially intensive. So they're just trucks going back and forth all day long. And so, there are areas where this is overwhelming the local ecology and the local towns. Okay. So it's not, all things considered, it's not a huge operation, but things like this are fairly intrusive. So one thing, just to kind of summarize all this, one other issue with fracking is that fracked wells, if you look at this chart, this is, if you take the average well, these are different fracking natural gas formations, okay? So if you take the average, let's look at the Fayetteville. So this is a shale layer. Um, the average well in Fayetteville, you start off, you're producing a lot. So this is your production, so millions of cubic feet per year in the well. So after 1 year, it's producing this much. After 2, 3, 4, 5 years, it's producing this much. So what you should notice from this chart is that the production drops very significantly, very quickly. So right away after the first year, first couple of years, you're losing 80, 90% of your production really quickly. So this can become a problem because then in order to keep the pace, you need to keep drilling more and more wells to keep up. So this is one problem. So the overall some highlights of the good news. Again, with natural gas, the carbon emissions are much lower. Okay, a lot of really good paying jobs and a lot of really good sort of blue collar middle class jobs. Folks with high school degrees or less are getting these high paying jobs to work out in the fracking fields. So it is good for the economy in the short term, absolutely. Landowners that are providing fracking leases are making a lot of money. Although that's kind of changing as the industry is maturing. But anyway, there's a really strong economic incentive to pull this gas out of the ground. Now, some of the bad news, methane is a very potent greenhouse gas, as I said, to the point that because of the leaks in the ground, the leaks in the pipes and the wells and so forth, even though it burns a lot more cleanly, so there's less CO2 when you burn it, there are peer-reviewed studies that are saying that the leaks may be so bad that it actually totally counteracts any any benefits of using natural gas instead of coal. It uses a lot of water. It contaminates water. There's all kinds of social, economic, political, environmental issues. I mean, again, this is a huge, huge issue, really complicated. A lot of sectors and people and factors, and I mean, there's politics involved, and there's economics, and there's all kinds of stuff. So there's a huge bevy of issues that it's a very divisive issue in a lot of areas of the country. One last thing that I wanted to mention is one interesting thing about fracking is that since we've had so much of it, it's actually kept the cost of electricity down, which has made it not as beneficial to use renewables. Okay, and so that is one sort of problem with fracking is if you're promoting renewable energy, if electricity is not as expensive, which is good for people in general, but if if you want solar panels to be worth more money, then if the electricity costs are higher, then solar is worth more. So there are there are pros and cons to everything. And one thing I want to mention is that the reason I focused on natural gas is that it's a huge issue. It's not going anywhere. Fracking's not going anywhere. There's a lot of moving parts here. Moving forward, we're going to be fracking, so it's important that you kind of have a general understanding of some of the basics of fracking, some of the issues surrounding fracking, and hopefully this will help you if you see or hear about fracking in the future. This will help you.